All right, tonight what we're going to be talking about are the two types of bonds that you're going to need to know in this class. The first one is ionic, and the second one is covalent. And these two types of elements bond very differently. Ionic is where electrons are given or taken between the elements, and covalent is where they actually share the electrons in between the elements. And it all comes down to the valence electrons of the elements that are being bonded. Valence electrons, once again to reiterate, are the ones in the outermost energy level. They're the ones involved in bonding and chemical reactions. They have a maximum of 8 unless you are helium, which has a max of 2. And therefore, if you count across the columns, because every column has the same number of valence electrons, you look at the noble gases and they have the most at 8 or 2 for helium. The reason why elements react or create bonds is because of this lovely octet rule. And what the octet rule is it's based off of the number, well, I'm hoping you can get it from the oct of 8. As you know, oct is a prefix for 8, so you can think of October, you can think of octagon, you can think of octopus, and you'd probably go into your head, wait, October? October is the 10th month. Well, in fact, a while ago, during the Roman times, we have Julius and Augustus come along, and they wanted their own months. So what they do is they inserted their own months, thus making October 2 months later. For July and August, they made their months earlier than October, so October now, instead of being the 8th month, became the 10th month. Well, what does the octet rule deal with when we're talking about valence electrons? What it says is that all elements, no matter what, want to achieve 8 valence electrons. So what that means is they will give up enough electrons to make it have 0, or they will gain enough to make their 8. No matter what they have to do, they will try to get those 8 valence electrons to reach that octet rule. All right, so what happens? Well, if you look at lithium, lithium has 1 valence electron. So it has 2 options. It can either gain 7 to make 8, or it can lose 1 to make it have 0. What is it going to want to choose? We compare the numbers, 7 versus 1, and it's always going to choose the least, so that would be losing 1. If you lose an electron because you're losing something that's negative, you go plus. So that's why lithium has a +1 charge. Magnesium. If you look at magnesium, magnesium has 2 valence electrons. Okay, so it's got 2 options also. It can either gain 6 to make 8, or it can lose 2 to make 0. So what is it going to want to do? Once again, 6 versus 2, it's going to choose the lowest, so it would be losing 2. So that's why magnesium will have a +2 charge always. Beryllium, if you look at beryllium, beryllium has 3 valence electrons. So it has 2 options. It can either gain 5 to make 8, or it can lose 3 to make it have 0. So what is it going to choose? 5 versus 3. It's going to choose to lose those 3. So that's why boron always has a +3 charge. Anion examples, if you look at neon or nitrogen, nitrogen has 5 valence electrons. So it has 2 options also. It can either gain 3 to make it have 8, or it can lose all 5 to make it have 0. So we're going to compare 3 versus 5, and 3 is obviously a smaller number, so it's going to choose to gain those 3 electrons to make it have 8. And whenever you're gaining a negative, you are going to be, or gaining electrons, you are gaining a negative, so that is why nitrogen has a -3 charge. When you look at group 8A, that is the noble gases, why did they not have any charges? Well, you look at, let's say, argon. Argon has 8 valence electrons, so it will either choose to gain 0 to make 8, or it will choose to lose all 8. Well, which one is it going to want to do? It is going to want to gain nothing because it's already perfect as it is. So that's why they never have a charge. That is why they never react, because they are perfect as they are. Okay, why do alkali metals, why are they the most reactive? Well, alkali metals only have 1 valence electron. 1 valence electron, to make it have 0 is a lot easier than to lose 2. So therefore, the alkali metals will lose its 1 valence electron a lot more readily than an alkaline earth metal, which would have to lose 2. The more able you are to lose or gain electrons, the more reactive you are. So group 7A, when we were talking about the halogens in that column, it has 7 valence electrons, so all they need to do is gain 1 valence electron to make 8, as opposed to their other nonmetal friends that will need to gain more than 1. Gaining more than 1 electron is more difficult and not as readily done as just gaining 1, so that's why halogens are the most reactive. All right, so now we're going to talk about something called Lewis dot structures. And Lewis dot structures, well, they use dots to represent the electrons. And the only thing Lewis dot structures care about are valence electrons. And all they're going to do is just show you a pictorial of what's happening with these valence electrons for an individual element. All right, so how do you draw a Lewis dot structure? First, you need to draw the element symbol. So for sodium, we're going to draw Na. Then you need to figure out how many valence electrons there are. You're going to put the sodium around or in a box where it now has 4 sides. Each side can hold up to 2 valence electrons, but if at all possible, you do not partner the valence electrons up. You want to separate them as much as possible. And the reason why is because electrons are all negative, and negatives don't want to be by other negative charges. They would want to split up as much as possible. What I like to think of it as is sibling. If you had a possibility to be in separate bedrooms, would you want to be in the same bedroom with your sibling? And almost everybody, hopefully, or probably, would say that they want to be in separate bedrooms if at all possible. So for sodium, we only have 1 valence electron. So what I'm going to do is I'm going to not draw this box. I'm going to imagine that the box was there, and I'm going to draw the 1 valence electron. Now, it's called the Lewis dot structures because that's what we use. We use a dot to represent its valence electron. So sodium could be written with its valence electron up there. You could have drawn it on its side right here. You could have drawn it at the bottom. It doesn't matter as long as I'm grading it, it shows 1 valence electron by itself. Let's try magnesium. So for magnesium's Lewis dot, you just draw the element symbol. Magnesium has 2 valence electrons, so what you're going to do is put 1 valence electron somewhere and another valence electron on one of the other sides of that imaginary box. Make sure that they do not partner up. What you could do is, if you wanted, you could put them on this side at the bottom, or you could put them on the other side. It doesn't matter which side you put them on, as long as they're not partnered up. Right now, these are considered lone electrons. Okay, so now I'm going to try oxygen. Oxygen has 6 valence electrons. So what we're going to do is, I always like to work at the top and work clockwise. So I'm going to do 1, 2, 3, 4. I have 2 more valence electrons, but I have no new sides. So now I am going to have to partner up. That's 5 and 6. So what these guys right now, these are called lone electrons or unpaired electrons. And these are considered paired electrons. We call them lone pairs. So lone pairs. Why? Because pairs are meaning that they have 2. So there are 2 of them, and they are all by themselves. So they are alone. All right, now we're going to deal with chlorine. Chlorine symbol is Cl, and it has 7 valence electrons. So it would be 1, 2, 3, 4. Now I need to partner them up. 5, 6, 7. So this one would have 3 lone pairs and 1 lone electron. All right, what happens then is, because of these lovely drawings, so we've got sodium. I'm just going to recopy these down for you. All right, so I recopied those exactly from what before, and now we're going to make them ions. So remember, everybody wants that octet rule, so they either want to lose all of them or gain enough. So what's going to happen is that sodium is going to lose its 1 electron, so it's no longer going to have that. And whenever it loses or gains electrons, what you need to do to show that it changed, you put brackets around it and you give it its charge. Sodium in this case lost 1, so you'd give it a +1 charge. Magnesium will choose to lose its 2 electrons, so goodbye, goodbye. Now because it lost 2, you're going to put brackets around it and give it its charge, which is +2. Oxygen, on the other hand, will want to gain 2 electrons. So what I'm going to do is show it gaining the 2 electrons. I too am going to put this now in brackets, and give it its charge. Well, it gained 2 electrons, so I'm going to do a minus 2. Whether it gained or lost, you still need to use brackets to show that there's somehow a change. Chlorine, on the other hand, has 7 and wants to only gain 1 to make 8, so I'm going to draw one more. I'm going to put this guy in brackets and give it its charge of a minus 1. You do not need to use different colors. In fact, you'll probably just be using the same color throughout, and it does not matter. I'm just trying to show you with different colors to help you out and visually see where that lone or the extra electron is going to. All right, as I said, there are 2 types of bonds. There's ionic compounds and covalent compounds. Ionic, if you look at the word, it has the word ion in it. And how are ions formed? Well, you either gain or lose electrons. And that's exactly how ionic compounds are formed, is they are gaining or losing electrons from different elements. How do you make it up? You're going to do a metal plus a nonmetal. The properties of them is that they are very high melting and boiling point, so typically they will be solids at room temperature. They are good conductors of electricity when they are molten. Molten means when they are melted, so in the liquid state, or dissolved. Okay? And they form crystalline solids, meaning they form crystals. How you identify an ionic compound by looking at its formula is you look at the first element, okay? So in this case, I'm writing CaCl2. I'm going to look at the first element, which is Ca. I'm going to look on the periodic table, and I'm going to identify whether it's a metal or nonmetal. If it's a metal, it's going to be ionic. If it's a nonmetal, then it would be covalent. So in this case, Ca is a metal. It's to the left of that staircase, so therefore it would be considered an ionic compound. And once again, these are formed by gaining or losing electrons. So these elements, calcium and chlorine, have gained or lost electrons to make the ionic compound. Then we have molecular or covalent compounds. I always think of co. So co means I think of coordinate or cooperate, and that's to work with. So what happens with covalent compounds is that the electrons are working with each other, or the elements are working with each other, and they are sharing their electrons. So covalent compounds share each other's electrons. There's no give and take, but they are mutually sharing at the same time. How you identify them is that you have two or more nonmetals, and it always starts with a nonmetal. Their properties are that they have a low melting or boiling point, so typically they will be a liquid or a gas at room temperature, and they do not conduct electricity. So if I were looking at an example of CO2, to identify whether it's ionic or covalent, I'm going to look at the first element. So I'm going to look at C. Is it a metal or a nonmetal? In this case, C is a nonmetal because it's to the right of that staircase, so therefore it would be a covalent compound. If it was a metal, it would be an ionic compound. All right, so what we're going to do is explain visually using Lewis dot structures why do they give and take electrons? And we're going to focus on NaCl. So Na, as we've already drawn, has 1 valence electron. Cl, on the other hand, has 7 valence electrons. Okay, so Cl wants to gain an electron, Na wants to lose an electron. So what's going to happen is Na is going to donate its electron to Cl. So now Na is happy with 0 electrons. As I showed in the ion section, what you're going to do is you're going to put it in brackets, make it have its 0 electrons now that it has, and give it its charge of a +1. Cl, on the other hand, will have gained that 1, so it will be happy because it now has 8. So you're going to draw it just like an ion. You're going to draw it to the side, give it its charge, give it all of its new valence electrons, which is 8, put it in brackets, and give it its -1 charge. All right, so looking at this is why an ionic compound forms, is because Na wanted to give up its electron. Metals always want to give up their electrons. Cl wants to gain an electron. That's what nonmetals want to do, is they want to gain electrons. And so you have a very happy relationship where one wants to give up, one wants to gain. Covalent compounds, what I'm going to want you guys to do is we're going to do F2. So what that is we have 2 F particles, or 2 F atoms. So I'm going to draw them in different colors so it makes it easier. Each F has 7 valence electrons. Okay? So what's going to happen is that both F's, this is really hard to see, I think. Sorry about that. So when you look at this, F both Fs want to gain one electron. The problem is that if both want to gain, neither can be perfectly happy. So what they do is instead they form a covalent bond where they are sharing these electrons. And what they do is they kind of psych each other out, and they're pretending that they both have these two electrons that are being shared at the same time. So now if I were to count the F on the right, it has 2, 4, 6, and even though it doesn't technically always have the electrons that are involved in the bond, it pretends that it has that 8 from that 2 from the bond. So therefore covalent, as you notice, they are sharing those electrons. All right, hopefully you understand how ions are formed based off their Lewis dot structures and how their Lewis dot structures can affect the types of bonds that are formed. Remember, ionic compounds start with metals and covalent compounds start with non-metals. All right, thank you so much and have a great night.